All right. So the leading coefficient test. So this is the formal name that we give to the observations that we noticed yesterday throughout the activity. And it has to do with finding the degree and the leading coefficient of a polynomial. From just those two pieces of information, we should be able to determine what end behavior the polynomial graph will have. And so what we're going to list out here in this chart is we are just going to summarize those four situations. Let's start with the first scenario of the degree of our polynomial being even. We know that the degree is the largest exponent that we see. And one of the situations we saw yesterday is that the degree was even, and the number out in front, the leading coefficient, was positive. And for that scenario, we saw that the end behavior was up in both directions. So the far left side and the far right side both had arrows that were pointing upwards, essentially going to really, really big numbers, eventually going all the way up to positive infinity. Now some students, when they're describing end behavior, will just put the little arrows in, as we've done here, up. But another option is you could use words. So you could say this end behavior is up, meaning the arrows are pointing up on both sides. So the really basic polynomial that I think about for this first scenario is the graph of y equals x squared. Just because it's one that we're already so familiar with, notice that we have an even degree. The highest exponent, the only exponent that we see, is 2. And we have a positive leading coefficient, really just because we don't have a negative in front. It's like an invisible positive 1. And we know that that's this basic parabola shape that is going to have that end behavior of both arrows pointing up. Other polynomials might have other things going on in the middle, like ups and downs and turning points and curves and all of that stuff. But this scenario will always be up. All right, let's look at the next scenario here. We saw that if the degree is even, another possibility is that our leading coefficient could be negative. And if that's the case, our end behavior, arrows are pointing the same direction, but this time they are pointing down. So we could describe it with the arrows, or we could use words and simply say down, down. And the one that I think about to remember this is the graph of negative x squared. I know that when I put a negative in front of the x squared, it's going to flip the parabola over, and it's going to make it look like the parabola is now opening down instead of up. And sure enough, I'm going to see those arrows pointing down, down. Even degree, and we have a negative in front. All right, the last two scenarios here are both going to be the case when the degree is odd. So maybe the highest exponent that we see is an odd number. And if that's the case, and you happen to have a positive leading coefficient, I'm going to fill this one in first. This is now where our arrows are going to be pointing different directions. And this scenario is when the first arrow is pointing down and the second arrow is pointing up. So I'm going to describe this scenario as being down, up. All right, a way to remember this, what I want to introduce to you here is the basic shape of the graph x to the third, or you could say x cubed. So this one is down, up. It's kind of like the graph of y equals x, which is just a straight line. The only difference is that there's a little curve in the middle. There's a little wiggle, or there's a little bend. That's what that cubed part does. But it still is low on the left side and high on the right side. All right, let's look at the last one. So the last one is if we have a degree that's odd and a leading coefficient that is negative. Arrows are pointing different directions, and it's just the opposite of what we did before. So this time the first arrow is pointing up, and the second arrow is pointing down. Now, if we think about that basic shape of x cubed, that little wiggle, well, if we were to put a negative in front of the x cubed, let me try this again. All right, y equals negative x cubed. Okay, what that negative is going to do, it's actually going to do the same thing that it did to our parabola. It's going to take this wiggle shape here and reflect it over the x-axis. If you think about this flipping, that means the part over here that's going up is now going to be going down, and then the part at the front that's going down, when it flips, now it's going to be going up. So it's just going to look like it's going the opposite direction. It's going to look something like this, and so we can see that it matches up with those arrows of being up, down. Okay, so let's talk about strategies for how we are going to use this information, how I suggest you use this table. At first, you're going to want to make sure you have this in front of you. So questions that you're answering, your goal for an equation that you look at is going to be to identify the degree, identify the leading coefficient, look at this table, figure out what category it matches, use this table here to answer the question for the end behavior. Now, eventually, once you have done this many, many times using the table, you might start to remember some of these. And so eventually the goal is to know this completely from memory. And so eventually I wanted to show you another idea. So this is something that I've had students do in the past. So ultimately, like by the day of the Chapter 5 test, even sooner if we can, we want to know all 4 situations by heart. And so I've had some students before do flashcards. And so this would be the front side of 4 different flashcards. So what they're writing out is what's going on with the degree, and then they're just saying that the leading coefficient is positive or negative. And then I'm going to show you what they put on the back side of the flashcard. If you like the words up, down, you can do that. I personally really like the arrows. This student just did the arrows. And so this could be a way to quiz yourself. So they would shuffle up the flashcards, and then they would just quiz themselves on each scenario, look at it, and then think, okay, what's going on with the arrows? And then you can turn around, and check yourself, and that can be a way to eventually memorize them. All right, so with that, knowing that we're still on the early end of this, we're going to be utilizing this chart for a little while at the start. We're going to practice now. So right above that in your packet, I want you to go ahead and work through equations A, B, C, and D. So for each one, when it says degree, you're going to actually write in what is the degree. So this answer is going to be a number. So for example, on equation A, I'm looking for the largest exponent. It's not always the first exponent, but I'm noticing on this one, the largest exponent that I see is 8. And then I'm also going to be looking for the leading coefficient. So the leading coefficient is the number out in front of the term that has the highest exponent. Well, I don't actually see a number here, but that's going to be an invisible positive 1. So that is my leading coefficient. And then something that I also like to do to help me figure out then the end behavior is I'm going to categorize these. So I'm going to notice that my degree is even, and then I'm going to notice that my leading coefficient is positive. And then I'm going to look back at my chart, and I'm going to figure out which one it is. When it says end behavior in the last column, you can either do the arrows or use the words up and down, wherever that might apply. So I'm going to give you a little bit of time to finish equation A, and then try the next 3. All right, everyone. So nice job. So just one last chance here just to check in on our answers. So our degree, we're just determining if it's even or odd. We have both of our even degrees listed first, meaning our arrows are going to go the same direction. Leading coefficient is either positive or negative. Notice that you would never have a negative degree, so just want to point that out. Remember that you can't have a negative exponent in order for it to be a polynomial. So the only thing that could be negative is the leading coefficient. Degree is always just looking if it's even or odd. All right, awesome job. Okay, let's talk about these 2 different forms. So we're going to go down below our leading coefficient test, and we're going to look at these 2 sides here. We've got standard form versus factored form. So up until this point, our main focus over the last few days has been looking at standard form. Now, standard form looks like this. This is where we see terms that are separated by plus or minus signs. We also talked about on the very first day, the other small detail about standard form is we want the exponents to go down in order. So we want the highest exponent listed first, with the exponents getting smaller as you go on. So that is standard form. And we've seen so far that in order to find the degree, it is the largest exponent attached to a variable. So for example, in this case, the largest exponent we see is 3. It's not always the first exponent. A majority of the time it is, but sometimes that largest exponent is in the middle or it's toward the end, so we need to check them all. The leading coefficient is the number in front of the term with the largest exponent. So our leading coefficient, in this case, is 2. All right, so we know all of that. All of that should sound familiar. Now we're going to change things up a little bit. So when you take a look over at the other side, factored form, this is a much different way of writing out a polynomial equation. What I want you to notice here, the main thing to see is that there's factors that are now in parentheses that are being multiplied together. So if you think about the factoring work that we did back in Chapter 4, we were factoring very simple polynomials at the time, but factored form always involves getting parentheses. What's happening here in between each piece is there's like invisible multiplication signs. So it's kind of like the x squared is being multiplied by the quantity x minus 1 to the third, and that's being multiplied by the quantity x plus 4. So we are going to think about a very different process when we're figuring out the degree. Ultimately, what we need to know is if we were to multiply this whole entire thing out, that would take some time. We could do it. But if we were to multiply it all out to make it look something like this, what would the largest exponent be? And so it turns out you don't actually have to fully multiply everything, but you do need to think about how many x's are being multiplied together. So here's how we can break this up. The first factor is x squared. So I'm going to think about an x squared being multiplied by however many x's I have represented in the second factor. In the second factor, notice that we have an x inside parentheses that's being raised up to the third power. What's represented there is an x to the third. If I were to multiply that whole thing out, x minus 1 times x minus 1 times x minus 1, and go through a big multiplication, I would have an x to the third at the very front of it. So we're going to put an x to the third here in the list. All right, now looking at the last factor, that is multiplied by just a single x. Technically, it's raised up to the first power. It's kind of like there's an invisible 1 out there. X to the first power is really just the same thing as x. So in thinking about what my biggest exponent would be if I did multiply the whole thing out, is thinking about x squared multiplied by an x to the third multiplied by x to the first. Now, if I were to really break this whole thing up, x squared is really x times x. X to the third is x times x times x. And then I have one more x at the end. So if we can see how many individual x's are being multiplied, we could simply count them, and there's 6 of them. So if x is being multiplied by itself 6 times, that's the same thing as x to the 6th. So what that's telling us here is, again, if I did take the time to multiply this whole long thing out, it would equal something that looks like this, x to the 6th, plus or minus a lot of other things behind it. But good for us, for the degree, we don't actually have to know what all of those other terms are. We just have to know the one that has the highest exponent. And we just figured it out, it's x to the 6th. Now, we don't have to do this whole thing with x's every single time we want to find the degree in factored form. What we could have done instead is simply add together the exponents that we see. So going back to the original problem, notice that we had an exponent of 2, and then we had an exponent of 3, and then we had an exponent of 1. Notice how altogether that's giving us the 6 that we found earlier. So that's how we know that it's a degree of 6. So we want to be really careful in what process we're using to find the degree based on the form that it's in. What we don't want to do is add the exponent if it's in standard form. No, just get the biggest exponent. Also, what we want to avoid is don't just find the biggest exponent when it's in factored form. No, this is a scenario where we need to add them. So we're going to be careful with the method that we're using. Now, the leading coefficient when it's in factored form is really not too difficult. It's simply the number that's out in front of the very first factor in the list. In our case today, our first factor is the x squared, that's yellow. Again, I don't see anything out in front there, so that's going to be an invisible positive 1. So in our case, our leading coefficient is 1. Sometimes you will have a negative sign in that position, so your leading coefficient is negative 1. You also could have something like a 2 in that position, or maybe like a 5. So maybe you have like an actual different number, but it's just whatever number is out in front of the whole thing. All right, so with that information, I would now like you to apply this along with the leading coefficient test for end behavior, and I want you to try this next section. So you're going to first identify what form the equation is in, then you're going to identify the degree very carefully, what's the leading coefficient, use those two pieces to fill in your end behavior. Do we have any other questions at this point for anything that you filled in on this section? Awesome. Okay. The last thing that we're going to look at today, what I have seen in the past that students have the most trouble with this section is what to do with the degree. So it can start to get confusing and tricky to know what to do for the two different scenarios. Sometimes we get them mixed up. And so what we're going to finish with, if you turn your paper over to the next slide, is we are going to just use kind of one last practice section directly comparing the differences between standard form and factored form. We're not focusing on end behavior for this section as much as we're just focusing on degree, because degree is a tool that eventually helps us get end behavior. I'm going to give you a little bit more time now to go ahead and complete all of the questions on this page. All right, so we're going to finish up here. We're going to come back one last time to check in. So here I have some examples. Your answers might be slightly different for the pieces at the bottom, but we should have something very similar at the top. So big idea when it's in standard form, as the degree is the highest exponent. Factored form is the only time that we add the exponent to get the degree. One thing I noticed when I was working through the notes, when I saw these four equations, I was like, those look really familiar. Yes, those were the four equations that we just saw on the previous page, but it's not bad to take a second look and do those again. So those are those same degrees. We might have different equations here for the examples. But what we are looking for is that the standard form looks like this. There's no parentheses. The highest exponent is 5. What we're looking for in the factored form is that you have parentheses, and when you add the exponents attached to every factor that involves an x, in my case it's going to be 1 plus 2 plus 2, that adds up to 5, so they both have a degree of 5. And then we have some error analysis. We have a disagreement here that we want to solve at the very bottom for who is correct and why. The student who was correct is the one who's saying that the degree is 4, and that's because this one is in standard form. There's no parentheses, so we we are just looking for the highest exponent. So we don't want to fall into the trap. The other student was getting it confused with factored form. They were trying to add the exponents when in fact they did not have to add them. Just look and see what was the highest one.